dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go. My dear friends, the agenda behind the series of the engineering mathematics which we have been running so far must be clear to all of us. The student who have been new to this video, they may not be knowing exactly what has been the basis behind the series of the engineering mathematics which we have been running. We are actually understanding the concept of the engineering mathematics from very basics. In the same sequence, 18 number of videos are already made live. The timing and the schedule must be known to you. We precisely start at 9 p.m. and approximately we go till 10 p.m. That means we are going to spend around 1 hour in totality in daily basis. Could you know, so just wanted to ask from each one of you regarding the quality of video as well as audio. So Prachi Soni says perfect. Anyways, before go ahead with the today's agenda, let me discuss what are the different topics we are going to cover in today's lecture. If you guys would have attended my last lecture, in last lecture I have taken around 6 to 7 well crafted number of problems which were based on the concept of continuity as well as differentiability. In the same sequence I have taken around 6 to 7 number of problems which I have crafted by myself, and we are again going to discuss the same concept, and that had been continuity as well as the differentiability of the function over its test point. Okay, so without getting delayed, let me straight away hop into the working board. The first question of the day would be, I need to find or I need to test the continuity as well as differentiability of a very important function e to the power of minus x square. May I know where this function has been foreseen? If you will go into the probability distribution and density, within the probability distribution and density, we would be discussing about the normal distribution, which is also called as Bell distribution, or it's also called as Gaussian distribution. There e to the power of minus x square would be a very important function. E to the power of minus x square would be a very important function. I wanted to ask from each one of you, how would be the nature of e to the power of minus x square throughout the range of x? Would it be continuous throughout the range of x? That means it starts from minus infinity till plus infinity. Would it be differentiable throughout the range of x? It starts from minus infinity till plus infinity. I want the answer over the live chat. If the answer is the function is continuous throughout the range of x, you should write continuous. And if you think the function had found a little bit discontinuity points, you should write the value as or the result as discontinuous. Tell me what would be the best most answer for this given problem. And even at the last, we will try to draw this curve over the Desmos itself. See, whenever we have this sort of problem, how do we start with? So here goes my solution. Let me recall the function f of x is equals to of e to the power of minus x square. Once again. See what had happened over here. At very beginning, we would be discussing about the continuity of this function. My dear friends, this function cannot be discontinuous at any moment of x. Why? Because it had been e to the power of minus x square, and x square had been a continuous function. Why? Because it's a second degree polynomial, and as we have seen earlier, if you take any degree of polynomial, that polynomial would always be continuous as well as differentiable. Not only that, if you take in totality minus x square as a second degree polynomial, then also minus x square is gonna be a continuous function. How the x square looks like? It used to be upper facing parabola, and how the minus x square looks like? It used to be a lower facing parabola. And if any of the continuous function has been raised to, just try to understand what I am saying. If any of the continuous function has been raised to a certain real value, the function would always be continuous in behavior. Could you understand what I am saying? Just I wanted to say over here, you had minus of x square, as well as it has been raised to exponent. Exponent had got a certain value, 2 point of something. And similarly, instead the e, if it would have been 2, 3, 4, 5, 6, the same concept would prevail. What it is, e to the power of minus x square is a continuous function which has been raised to a certain real number. Whatever the function you frame, that would always be a continuous function. As such, no doubt you should have. Agreed? In the same sequence, even it could have been crafted in the form of 2 has been raised to minus of x square, even 3 has been raised to minus of x square. So at least one padav is getting crossed. What it is? The function is being found as a continuous throughout the range of x, which can start from minus infinity and can go till plus infinity. So one of the important conclusion at least I can retrieve out of this. If you want, you can write somewhere here. If a function f of x has been raised, or a function g of x has been raised to a power to a certain real value, result would always be continuous provided the g of x has to be continuous. Could you understand what I am saying? So from here, another important aspect I am going to retrieve. May I know what it is? If you had a function f of x which had been been raised by another function g of x, and if g of x had been a continuous throughout the range of x, or in short, if g of x is a continuous function, by default f of x would also be a continuous function. Continuous function. Could you understand what I am saying? So till this point, nobody should have any doubt as such. Nobody should have any doubt as such. Now let me come back to the same function. F of x is equals to of e has been raised to be minus of x square. What about its differentiability? How many number of students are concurrent viewing? The 9 number of students are concurrent viewer. At least 2 or 3 number of outputs I want from the current viewers. What about the differentiability of e to the power of minus x square? What about the differentiability of e to the power of minus x square? I would like to have the input from each one of you. I would like to have the input from each one of you. So if you do not exactly able to monitor about its differentiability test, obviously I can have the test over x is equals to 0. Obviously before x is equals to 0 and after x is equals to 0, this function is going to be completely or perfect differentiable. You can have a problem over exactly x is equals to 0. So what I am going to do over here, the differentiability test is getting performed at x is equals to 0. Could you understand what I am saying? So let me bifurcate this digital board into 2 parts. The differentiability test is applied over the given univariate function applied at x is equals to 0. There are different methods through which I could have what applied the differentiability test at x is equals to 0. Either I could have used the classical method where I used like f of c plus of h minus of f of c divided by of h, where the h tends to 0, so on and so forth. But that classical method takes hell amount of effort, hell amount of time. So what I would be doing over here, I would just be using the short trick. I would perform the differentiation of e to the power of minus x square, and will calculate its worth just before 0, which I would be calling it left hand derivative, and just after 0. And the function had been found to be continuous. There should not be any doubt as such. And here I would be calculating at 0 plus. That had been RHD, right hand derivative. Right hand derivative. Tell me what would be the differentiation of e to the power of minus x square. Once we take the differentiation of e to the power of minus x square, what happens? Obviously, e, let's take minus x square had been taken as another variable t. So e to the power of t would be e to the power of t, which would be brought back as a e to the power of minus square. And now there would be the differentiation of t with respect to the x. So obviously minus of 2x is getting multiplied over here. And end of the day, you are going to feed the worth of x as 0 minus. Nobody should get confused. It's not minus 0, it's 0 minus. That means you are approaching towards 0 from the left hand right, and you have stopped yourself somewhere. Let's take minus 0.000001, just before 0, just before 0. And the same process goes over here. The same component you would be getting over here. Here it goes e to the power of minus x square minus of 2x 0 plus. See, if you had the x towards the denominator side, no, in that case the x is equal to 0 minus as well as the 0 plus would make a lot of differences, because the 0 minus would make this value as minus infinity, as this as plus infinity. But as far as this outcome is being concerned, this x is simply getting multiplied towards the numerator side. Put together, if x has been fed as a very nullified value, let's take it 0. So minus 2 into 0 would become 0. 0 is getting multiplied with the e to the power of minus 0 square, again becomes 0. Could you understand what I am saying? So it would be simply equals to of. I have seen many of the times the student do have one doubt, sir, why you are writing 0 minus and why you are keeping here as 0 itself. My dear friends, 0 minus, what does that mean by the 0 minus? You have stopped yourself just before 0. The worth is almost 0. The worth is almost 0. Yes. So here it going to be e to the power of minus, and here it's going to be minus 2 into 0. Left hand derivative as well as right hand derivative had been found to be same. And yes, my dear friend, from tomorrow onwards, I am going to start my EMFT on our Gate Academy 2.0. So probably time I would not be able to communicate until and unless the timetable is not getting fixed. So the student who are from electrical, electronics and instrumentation should follow those video. Again, we would be having a sort of complete course over the EMFT on our Gate Academy 2.0. Probably the timing would be 6:30. 6:30. Agreed now? Till this point, probably you could have understood each and everything. That means as far as the curve of e to the power of minus x square is being concerned, at x is equal to 0, the slope is found to be 0. That means the function would be lying in parallel with the x-axis, and LHD is equals to RHD indicates the function would be differentiable. There would not be any formation of curves at x is equal to 0. At x is equal to 0. Would you like to see how the curve would look like? So let me show how the curve would look like. Just a minute. So just a minute, let me see if I would be able to fetch it over here. So e to the power of minus x square, let me show how it would look like. It goes exponent of minus of x square, minus of x square. Let me show how it would look like, For that I need to go back, just a minute. I need to go back. I need to cast my mobile over the digital board. For gate and EAC, sir, yes. Sir, please start EMFT in Hindi. Yes, it would be perfectly in Hindi. Because whatever the videos are supposed to come on our Gate Academy 2.0, the mode of communication would be perfectly Hindi. And what are the different types of lectures as well as the videos which we are providing over the Gate Academy Global, the mode of communication would always be in English. Yes, our agenda has been very clear. Not now. Let me see how it would look like. So let me join this 0, 7, 4, 4, 8, 7, 8, 7. Let me see if it is getting connected. Yes, it is getting connected. Share my screen. It's getting shared. So here goes the curve. You could have seen very well. Here I have written this as exponent has been raised to minus of x square, and how curve would look like. Although it might be looking the curve has been formed at x is equal to 0, but it is not so. Once you will expand it, you yourself would be able to understand at x is equals to 0. Would you able to see what exactly I wanted to communicate? At x is equals to 0, if you will talk about the nature of the function is almost in parallel with the x-axis, and there has not been any formation of the curve. There has not been formation of any curve. If you want, I can show you over here. Just a minute. What I am saying over here, my dear friends, this had been your x-axis, y-axis, where the x used to be 0. So you can say this has been x is equals to 0. And at x is equals to 0, if you talk about the nature of this function, the function does not make any curves. That's the first thing. And if you talk about the tangent over the function at x is equals to 0, it would be almost parallel to the x-axis. Put together, the function is found to be differentiable. The function is found to be differentiable. That's the first thing. And that too, if you talk about the worth of its differentiation, would always be 0 at x is equals to 0. It is sir energy signal or something like Gauss distribution, my dear friend Satyam. It is a pure mathematics, and the mathematics would be explored in the different subjects as well as the different topics. Sometime in signal system it may become a energy signal, sometime in maybe probability random approach, or maybe in communication it would become a random process or type of distribution. Even in production engineering as well as mechanical engineering, when they talk about the failure rate or the distribution of the failed item, there also they use the same concept. So it's just mathematics which would be exploited in the different topics as well as in different subjects. So you need not to read anything related to the engineering mathematics as you are by hearting something, because the same concept would be used somewhere in your technical subject. Could you understand? Till this point, I don't find that any of us would have any sort of doubt. So let me go back. Let me go back into the working board. And end of the day, I would try to share this slide to all of you, as I did last. In the same sequence, let me move further, and we are going to go ahead with the next function, which we have discussed probably in yesterday's class. In yesterday's class, I gave this problem as the homework, which had been a function contains one independent variable, and that had been x. Let's take the function had been 1 divided by f 1 plus of mod of x. 1 divided by 1 plus mod of x. Again, we need to comment over its continuity as well as the behavior of its differentiability. Tell me, how would be the behavior of its continuity as well as differentiability? And you can expect this sort of problem may come in near future. Yes. Satyam, definitely I am going to continue my mathematics. And even my recording is also going in parallel. I am recording for the analog. So 3 subjects we are going to deal. Out of 3, the 1 would go in a form of recording and the 2 would go in a form of live classes over the YouTube, our Gate Academy Global, and the second at Gate Academy 2.0. Tell me, how will you go ahead? Anyways, let me start with the solution. As far as the function is concerned, you have got a function towards denominator side. Whenever the function towards denominator side becomes 0, or whenever you compare its denominator with the 0 and you find its roots, which we call it poles, the poles are the values of x where the function f of x are found to be discontinuous, which we have already discussed in the great detail when we were discussing about the concept of discontinuity as well as continuity. Could you understand what I am saying? Should I be repeating once again? Let's take you had a function f of x, and the function f of x had been a division between the 2 different functions. Let's take it had been g of x and as well as h of x. The roots of h of x would be called as the poles of the given cumulative function f of x. And the roots of the denominator or the poles are the values of x where the function would be discontinuous. May I know whether the function would be discontinuous somewhere at a complete range of x, or it would be continuous throughout the entire values of x? Mod x is not differentiable at x is equal to 0. That we'll see. See what is happening over here. At very beginning, if I start discussing about the continuity. Why we are start discussing about the continuity? Because if a function is found to be discontinuous at a certain point, definitely it can't be differentiable at all. So one thing had been quite sure, you had to start with the continuity. If function is not continuous, by default it won't be differentiable. See what I am going to see over here. I would be focusing over the roots of the denominator's function. May I know for any real value of x, can we have a situation where the 1 plus mod of x would become 0? Not at all. 1 until and unless is not getting added with the -1, the result would not be 0. May I know when you will be getting the result as -1? When you will be getting the result at -1? Definitely you cannot choose any of the real value of x. No, you can't. So one thing had been quite sure, what it is, there is no real poles for the given function f of x. What does it mean of it? That means the function would remain continuous throughout the span of x. The function would remain continuous. Function would be continuous. Where the x belongs to the complete or the entire set of real numbers from -infinity till +infinity. Obviously, it would be a continuous function. What's the reason? The reason could have understood to each one of you. Similarly, if I take another problem like 1 divided by 1 plus of x square, there also the same concept would apply. How? the x square indicates the x square, the factor as a whole would not become negative at any moment of time, and as the x square is not getting negative, 1 plus of x square would never become 0 for any possible real value of x, and put together the function would again be continuous. So in future you may expect this sort of problem may come in a GATE examination, because once in GATE examination probably 10 years back they have asked f of x, where the f of x has been defined as a x divided by 1 plus of mod of x. Yes, could you understand till this point? I don't find that you guys would have any sort of doubt. So the continuity has been frozen. Continuity has been frozen. What has been frozen? The function would remain continuous throughout the range of x. Now it's turn for talk about the differentiability. May I know where the differentiability may come in problem, where the nature of mod of x would change? May I know where the nature of the mod of x would change? Obviously around x is equals to 0. Before x is equals to 0, the nature of mod of x is being minus of x, which we have talked about in the great detail when we were discussing about the absolute function, and similarly the nature of mod of x would become plus of x when we would be dealing with this function for x greater than 0. So obviously the x is equal to 0 has been the point of concern, So here I would be applying the differentiability test. I know many of these students used to have one doubt, sir, which test point has to be chosen? The test point has to be chosen where you find there could be certain ambiguity, that the ambiguity point had been x is equals to 0. That is why the test point has been chosen at x is equals to 0. Yes. So what I would do over here, let me recall f of x once again. How it had been? It had been 1 divided by of 1 plus of mod of x. Now what's happening over here? The nature of mod of x, as it has been communicated earlier, would be bifurcated based on the range of x. When the x is negative, the function would be referred as 1 divided by 1 minus x. And similarly, when x is greater than 0, the function would be defined as 1 divided by of 1 plus of x. So when you would be calculating the left hand derivative around x is equals to 0, definitely this function has to be taken in consideration, and when you will be calculating the RHD, right hand differentiation, around x is equals to 0, this function has to be considered. So what I am going to do over here, I would calculate left hand derivative of the function around x is equals to 0. Left hand, that indicates obviously 0 minus, and similarly right hand derivative has to be calculated of the function around x is equals to 0. Okay, left hand derivative, that means the differentiation has to be carried out for which function? The function which has been valid towards x less than 0. May I know which function had been? This had been the function. So obviously we would be taking the differentiation of it. End of the day, I would be feeding x is equals to 0. In the same way, what I would be doing over here, the differentiation has to be marked of 1 divided by of 1 plus x, and whatever the result you get, the x has to be fed as 0. Could you understand what I am saying? So in the same process, what we are going to do, we are going to take its differentiation, the differentiation of two functions which had been formed in a form of numerator and denominator. What we do? Towards the denominator, we raise the function in a power of 2. In numerator, what would happen? 1 minus of x would get repeated once again, and now there would be the differentiation of 1 with respect to the x that would lead 0. In next step, what we are going to do, the minus 1 minus numerator, and thereafter now it's turn to get the differentiation of the denominator which would lead minus of 1. Whatever the result comes, the x has to be fed as 0. In the same sequence, let me discuss about this. What are the different changes you will be expecting? See, instead the 1 minus of x, it would be 1 plus of x, which would be raised to 2. Instead the 1 minus x, again you will be having 1 plus x, although there would not be any major change because it's getting multiplied with 0. Agreed? In the same sequence, what we are going to do over here, minus, what would happen over here? The 1 would remain as it is, and now there would be the differentiation of denominator. Earlier there was a differentiation of 1 minus x along with x, result was minus 1, but now it would be plus 1. Agreed? Now what is happening over here? This factor had been already went out, that had become 0, minus and minus is becoming plus, divided by of 1 minus of x, which has been raised to 2. End of the day, again x has to be fed as 0 because the differentiation has to be taken along x is equals to 0. In the same sequence, what we're going to do over here, this factor becomes 1 plus of x square. Only one major change we have experienced, and that has been minus 1. Minus 1. Again, x had to fed as 0. X had to fed as 0. And once we will be feeding x is equals to 0, the result what we are getting over here, see my dear friends, the 1 is getting subtracted with the 0, that would lead 1 towards the denominator side, the 1 is getting divided with 1, the result would be precisely 1. The result had been precisely 1, and towards right hand side the result had been minus 1, and obviously they are not same. They are not same. What's the conclusion you can derive out of this? The conclusion has been very crisp and clear. If you draw the tangent over the f of x at 0 minus, the slope had been 45 degree, and similarly if you draw the tangent just after x is equals to 0, or you say 0 plus, the slope had been minus 45 degree, or you can say the unique tangent was not or cannot be drawn over x is equals to of 0. X is equals to of 0. So would you like to see how this curve would look like? So let me do one thing. Let me draw this curve over the Desmos, and then I will try to show over the screen mirroring. So here goes 1 divided by of 1 plus of mod of x. Here goes mod of x. Yes. Let's see, or let me show how the curve would look like. So let me go back first. Let me go into the screen mirroring. Once again, I need to connect it back. So just a minute. Enter the session ID, it's staying. Let me see that. 32322433176. Let's see if it gets connected. Yes, probably it's getting connected. Yes. See how the curve would look like. So this has been the same function for which I have framed the problem. The problem had been 1 divided by 1 plus of mod of x. As far as the continuity behavior of this signal is being concerned, now it had been continuous throughout the range of x. You can see very well there had not been any discontinuity for this function. Similarly, if you go for the positive value of x, the same thing had been found. There had not been any discontinuity at any moment of x. But at x is equals to 0, you could have seen there had been a formation of curves. There had been a formation of curves. Could you understand where it had been? So probably the student who have been following me from very beginning, they must be able to understand what exactly I wanted to communicate over here. So here it's happening at x is equals to 0. At x is equals to 0. Here there had been the formation of the curves. And as there has been the formation of the curves, you cannot draw the unique tangent at x is equals to 0. You can't draw, no. You can draw. No, you can't. You can't draw any unique tangent. But here if you'll say, can you draw the unique tangent? Obviously, sir, I can. Can I? Yes, sir, obviously you can. And one thing you could have seen over here, let me rub this out for a moment. Just before 0, which we call it 0 minus, if we'll discuss the derivative, which we call it left hand derivative, may I know what was the angle which it was made from the positive x-axis? Almost it was 45 degree, and as the angle had been 45 degree, if we'll talk about its slope, the slope would be plus of 1. And similarly, once you'll go at 0 minus, the slope had been changed to minus of 1, which we have already calculated earlier. Could you understand? So I expect that most of us could have exactly understood the crux behind this problem. Yes. In the same sequence, now it's right time to move ahead into the next question. Just a minute. Into the next question. So the next question, f of x is being decided as x divided by 1 plus of mod of x. Now this problem has been thrown to you guys. You had to talk about the two different conditions. First, the continuity as well as the differentiability of this function in the entire range of x or entire real range of x. This problem should not take more than 1 minute to get solved. So this problem has been thrown to you guys. You had to solve this problem and give the proper answer within 1 minute. 1 minute. If the problem is not visible, let me orally communicate what it has been written. F of x has been written as x divided by 1 plus of mod of x. Only one change has been introduced within this problem in compare with the last problem. In last problem, we did not have the component of x towards the numerator side, whereas in second problem, we had the x towards the numerator side and the denominator had very same. Very same. I would like to have the input from each one of you. I would like to have the input from each one of you. Still the same problem would pursued around x is equals to 0 as we had earlier, that the function was non-differentiable at x is equals to 0, or in this particular problem that problem would get removed. Tell me, the 11 number of viewers are there, not 11 number of replies, but at least 2 or 3 replies I want over the live chat, so at least I'll have the better understanding how far you guys are going to get the concept which has been taught so far. Tell me. You had to comment over its continuity as well as differentiability. The function f of x had been x divided by 1 plus of mod of x. I repeat, the function f of x had been x divided by of 1 plus mod of x. You had to comment about its continuity as well as differentiability. Or in short, you can comment over the live chat what are the different points of x where the function would become discontinuous and the function would become non-differentiable. Approximately 30 seconds is already over. So in next 30 seconds, you have to get the perfect answer for this given problem. Tell me, what would be the best most answer for this given problem? See, how we will start approaching this problem. Let me start with the solution. Again, the f of x had been the combination of the two different functions. Let's take it as a g of x as well as h of x. Until and unless you do not find the real value of x for which the h of x becomes 0, or I can say until and unless you do not have any real values of x which makes its pole, you will not be finding the situation where this function would become discontinuous. Again, the same criteria has to be applied over this problem which we have applied in the last problem. Continuity. For the continuity, what we do? We try to check the all possible real values of x which will make the denominator 0. So obviously I do not have any opportunity for the real value of x which would satisfy 1 plus of mod of x is equals to 0. One thing had been quite sure, the function would remain continuous for all possible real values of x. All possible real values of x. So the answer have started coming. The Alok says the continuous and differentiable. Prachi Soni says the continuous and differentiable perfectly well. And even Pradya Ingole says the continuous as well as differentiable. That looks perfectly well. In the same sequence, let me go ahead with the differentiability test. See, whenever you have this sort of function where the test point has not been clearly given along with this problem, you had to be smart and you had to find the test point at which the differentiability test has to be conducted. My dear friends, as well as this function is being concerned, the function had been uniform in nature except x is equals to 0, because before x is equals to 0 and after x is equals to 0, the mod of x would behave differently. So what I am going to do over here, by default the test point had been taken around x is equals to 0. Yes. In the next sequence, what I would be doing over here, I would bifurcate this function in terms of its nature in two different parts. When the study had been made when the x was negative, and when the study were made when the x was positive. How the function would look like? The function would look like x divided by 1 minus of x, and here it would be x divided by 1 plus of x. Again, the differentiation has to be taken place at x is equals to 0. Obviously, until and unless the LHD and RHD is not same, you cannot draw the unified or unique tangent at x is equals to 0 over the function would not be differentiable. So again, the LHD and RHD has to be found. How the LHD would be applied? The LHD, that means the differentiation has to be applied over the function which has been valid for x less than 0, which has been this, and similarly x greater than 0, that has been this. So let me calculate the LHD. LHD, what I am going to do over here, I am going to take its ordinary differentiation, and end of the day I would feed x is equal to 0 because my test point has been chosen at x is equal to 0. In the same sequence, what I would do over here, yes, so let me take the differentiation. If I take, or if I initiate the differentiation towards the denominator side, we are going to add 1 minus of x, which has been raised to 2. 1 minus of x would remain as it is. There would be the differentiation of x, which would lead 1 minus of x, and there would be the differentiation of denominator. 1 minus of x gets differentiated with the x, definitely would result minus of 1, In the same sequence, we are going to take the differentiation of the second term, and here it would be 1 plus of x square. Here it goes like 1 plus of x, differentiation of numerator, which would lead 1, minus of x, differentiation of denominator, which would lead plus of 1. End of the day, whatever the result we get, the x has to be fed as 0 over in first equation as well as in second equation, Till this point, probably each and everything must be clear to all of us. The Manju have also saying the answer would be continuous and differentiable, obviously. See what is happening over here. Now the 1 is getting multiplied with this, the result would be 1 minus of x, and here it becomes plus of x. And towards the denominator, it had been 1 minus of x, which has been raised to 2. X has to be fed as 0. Similarly, towards right hand side, 1 plus x is getting multiplied with 1, would be left out with the 1 plus x. 1 plus x is getting subtracted with the x. And towards denominator, we had 1 plus of x, which has been raised to 2. And again, x has to be fed as 0, end of the day. See, the same process has been followed towards left and right hand side. As such, there is no difference towards the numerator, but there had been the difference towards the denominator side. But as the x would feed as 0, even the denominator would also be same. 1 divided by 1 minus of 0, which has been raised to 2, would be 1 and would be 1. LHD has been very same as RHD. What's the conclusion we can retrieve out of it? That means the function had got the same derivative towards left hand side of x is equals to 0, towards right hand side of x is equals to 0. The function had a unique tangent over x is equals to 0. The function is differentiable. See how much change has been experienced by the function by just multiplying x towards numerator. And that's the beauty of the mathematics. If you'll recall the questions which we have taken, just before then this question, we had the absence of x towards the numerator side, and there the LHD and RHD were not same, and the function was found to be non-differentiable, whereby just presence of x, the function was found to be differentiable in the entire range of x. Why I am saying entire range of x? Because x is equals to 0 was only a point where I raised a question mark. Except x is equals to 0, there is no question mark at all. Would you like to see how this curve would look like? So let me draw over the phone. So only one change I am introducing. Instead the 1, I would be replacing with its x. Such a beautiful curve it's going to be. Again, I need to go back. Screen sharing has to be done once again. That's the problem with this. It is getting disconnected again and again, but I don't find so that it is getting much time to get reconnected. 176. Let me connect it. Let me present my screen. See how the beautiful curve has been over here. Just by presence of x over the numerator, the curve had been so beautifully crafted around x is equals to 0. X is equals to 0. And if you will try to draw the tangent over x is equals to 0, you yourself would be able to understand, yes, you can draw a unique tangent at x is equals to 0. That means the function is found to be differentiable around x is equals to 0. How would be the nature of that tangent? The tangent would be drawn something like this. And if you'll talk about the slope of this tangent, you'll get to know the slope is approximately equals to 1. And which was the worth of LHD as well as RHD. LHD as well as RHD. Let me go back. So what I am saying, we had the x over here. If the x has been knocked off and has been replaced by 1, such a huge change we have been experiencing over this curve. This has been the 2D curve for 1 divided by 1 plus mod of x, and this has been the 2D curve for x divided by of 1 plus mod of x. Such a huge difference it comes when we deal with the engineering mathematics. Yes, just wanted to from each one of you, could you really understood what exactly I wanted to communicate? If the answer is yes, just write yes over the live chat. So I'll have the fair idea that you guys are going to connect with my each and individual concepts which we have been discussing over the live video. In the same sequence, the next question goes to you guys, and definitely this problem is going to give you a lot of pain, and this problem has appeared once in gate electronics, and probably many of these students could not attempt this problem perfectly, and that had been f of x is equals to of mod of x cube, mod of x cube, mod of x cube. Yes, no? Yes. Tell me f of x is equals to of mod of x cube, mod of x cube. See, before going into the detailed study of this problem, let me clearly talk about the problem. I need to discuss about its differentiability test at x is equals to 0. Because before x is equals to 0 and after x is equals to 0, there would not be any change in the nature of this function. It would remain a strict polynomial, and the strict polynomial used to be a continuous function as well as differentiable function. So whatever the problem may get raised, that would be raised only at x is equals to 0 only. At x is equals to 0 only. So what I am saying over here, this has been a problem which has appeared in gate electronics once, and probably this had been one of the toughest problem which has been appeared in the history of gate. Because the problem has been framed in a very smarter way. What they have asked? They have asked the function f of x is being written as mod of x cube, has been differentiable once, has been differentiable twice, has been differentiable thrice. Alok Kumar says mod of x to the power of 3. Mod of x to the power of 3. We'll see that also. Mod of x to the power of 3. So this has been the function. Mod of x cube. Mod of x cube. So what the Alok is saying, the mod of x to the power of 3. We'll see that also. May I know, I would like to ask from each one of you. The Alok has asked a problem, sir, what about mod of x which has been raised to 3? And here the function which we have written over here had been mod of x cube. May I know, can we write mod of x cube is very same as mod of x which has been raised to 3? Whether both of them are same or whether both of them are different. I want the input from each one of you. Mod of x cube is equals to of mod of x cube. Sorry, mod of x to the power of 3, mod of x cube, whether they have been the same component or whether this statement is wrong. So just write over live chat. No, continuity and differentiability, everything leave about. First focus over the mod of x cube as well as mod of x cube, whether they have been the two different graph or whether they would be having the same graph. No sir, different. The Manju says, no sir, they would be different. Anyone else? A very good question was raised by Alok. The Alok says, sir, if you are talking about the mod of x cube, so what would happen with mod of x which has been raised to 3? Whether they would be the different in nature, whether they would be having the same graph in nature. Both different. Tell me. I want the input from each one of you. I know many of us are going to get stuck over this point. Many of the students are going to get stuck over this point. Mod of x has been raised to 3. mod of x cube, whether both of them would follow the same curve or whether they would follow the different curve. I want the input from each one of you. The Alok says different. Alok says different. Anyone else? Anyone else? Anyone else? Okay, let me come back to this problem once again. My dear friends, how the mod of x cube would look like, just try to understand what I am saying. How the mod of x would look like, I would take its bifurcation, taking the reference of x is equal to 0, if the x has been found lesser than 0 and x has been found greater than 0. Agreed? If the x has been found lesser than 0, may I know how the mod of x would be defined? The mod of x would be defined as a minus of x, and if the minus of x has been raised to 3, what would happen? The minus sign would get multiplied 3 times, would result a minus sign, and the x would become x cube. The result would be minus of x cube. Till this point, nobody should have any doubt. Similarly, if I go with the situation where the value of x has been greater than 0, what is happening over here? The mod of x would be defined as x itself, and now the x has been raised to 3. It would be defined as x of 3. So let me write it properly. The mod of x which has been raised to 3 would be written as minus of x cube when the x is less than 0, and similarly plus of x cube when the x is greater than 0. And as far as this curve is being concerned, at x is equals to 0, they have got the same value. Either I feed x is equals to 0 over here, or over here I am getting the worth as 0. So even I can write x lesser than equals to 0, x greater than equals to 0, x greater than equals to 0. Now the Manju says same, sir. We'll see that. Now let me come back with mod of x which has been raised to 3. If you don't understand, let me do one thing. Let me take its graphical curve. For that, I have chosen a xy plane. Here goes the horizontal axis. Here goes the vertical axis. May I know how the y is equals to of x cube would look like? At 1 it would be 1, at 2 it would be 8, at 3 it would be 27, it would be keep increasing, obviously. Similarly, if you'll go towards the negative value of x, at minus 1 it would be minus 1, at minus 2 it would be minus 8, at minus 3 it would be minus 27. So let me draw how the curve would look like. The curve would look something like this. Which curve it had been? It had been y is equals to of x cube. But now if you'll take, if it's determinant, if now you'll take its determinant, what would happen, my dear friends? The curve cannot be in third as well as fourth quadrant, because in third as well as fourth quadrant, the value of y would become negative, and if I am taking its modulus or absolute value, the worth of y cannot be negative. So once I apply the modula over the x cube, what are the changes you expect? This curve would remain as it is because the value of y was already positive, but this curve would get flipped towards upside. So end of the day, the complete curve which we are going to get, this curve would remain as it is, and this curve would get shifted upside. That means there would be the flip of this curve. So may I know what had been the nature of the curve? The curve had been mod of x cube is equals to, had been x cube for x greater than 0. And when we had x less than 0, may I know what's the change we had? The curve was very same as x cube, but now it was flipped taking the reference of x-axis. What does it mean of it? That means the minus got multiplied. Earlier it was x cube, now it has been changed to minus of x cube. And again the function is found to be continuous at x is equals to 0. Obviously the equal sign can be applied over here. So now it's your turn to judge whether, just a minute. The mod of x cube and mod of x cube, whether they are different or whether they are same. They are very same. Alok, you had that doubt probably. That doubt could have cleared till this particular explanation. So as far as the f of x is equals to of mod of x cube is concerned, definitely it could have also written as mod of x which has been raised to power of 3. which has been raised to the power of 3. Could you understand? So all of us are agreeing on this movement of point or not? If you're agreeing, just write agree. At least I'll have the fair idea that you guys are actually agreeing that conclusives is which I have explained over here. So what I'm going to do over here, what we are going to do over here, the f of x could be taken as mod of x which has been raised to 3. Yes. Sir, I wrote the answer of homework question. Yes, Himanshu, I saw. That is why, even I saw. That is why I thought to take the problem here itself. I saw that. Even I am going to reply in today night or probably tomorrow. I have seen that. Need not to worry about it. Yes. Same, no? See what is happening over here. So mod of x cube could have written as mod of x square into mod of x. Just to make this problem bit simpler, what I am going to do over here, mod of x which has been raised to power of 2, can I write simply this as x square into mod of x? Yes or no? I want the input from each one of you. So we started taking f of x is equals to of mod of x which has been raised to 3. That function has been changed to the mod of x which has been raised to 3. Now the mod of x which has been raised to 3 can be written as mod of x into mod of x into mod of x. Now starting mod of x has been taken together, which has been formed mod of x which has been raised to 2, and now separately I have taken this as mod of x. Mod of x. Could you understand? Can I take the mod of x which has been raised to 2 is very same as x square? Yes, I can. Why? See what the mod of x square says. Either you keep the x as positive, either you keep x as negative. Mod would always make it positive, and once you will take its square, you are just going to take the square of a positive value. And here, without taking mod, if you take the square of a certain positive or negative value, you would be getting the same value only, no? You would be getting the same value only, no? So what's the conclusion we can retrieve out of it? What's the conclusion we can retrieve out of it? So we can retrieve the conclusion like mod of x to the power of 8 can be simply written as x to the power of 8 because the power had been even. Mod of x to the power of 16 can be simply written as x to the power of 16. Similarly, if you have mod of x which has been raised to 19 can be simply written as mod of x which has been raised to 19. Simply this could have been written as x to the power of 18 or mod of x which has been raised to the power of 18 into mod of x. Could you understand what exactly I wanted to communicate? So these are the important conclusions which should be there in your mind. So f of x has been written as x square divided into of mod of x. So now let me discuss about its first differentiation. F dash x. So I would take the differentiation by parts. The first differentiation would take place for the x square. The mod of x would be kept as it is. Secondly, I would take the differentiation of mod of x. I would keep x square as it is. Could you understand what I'm saying? So let me take the differentiation of x square. The result would be 2 of x, mod of x would remain as it is. Similarly, here it goes x square, and here the mod of x, the differentiation of mod of x, what used to be the differentiation of mod of x, which we have seen earlier, that used to be x divided by of mod of x. That used to be the signum function. Signum function. Till this point, probably each and individual concepts must be known to all of us. Now, I should have the fair idea. What I am saying, I should have the fair idea at x is equals to of 0. I repeat, at x is equals to of 0, its first differentiation is possible or not. Its first differentiation would be possible only and only if the f dash x contains a unique value around x is equals to 0. Either at x is equals to 0 minus or either at x is equals to 0 plus. Why I am taking around x is equals to 0? Because the x is equals to 0 was a critical point where the function may become non-differentiable. Just plug the value and get the answer. Plug the value and get the answer. I know many of these students are just scratching their brain. What I would do over here. Now, x square, can it be written as mod of x into mod of x? Nobody can deny, yes, it can be. It can be. So here this mod of x and this mod of x is going to get out the 2x mod of x, and here it's a x mod of x. The result would be 3x times of mod of x. 3x times of mod of x. So the first differentiation of, that's the beauty of mathematics, the first differentiation of mod of x cube, which has been written as this form, is very same as 3x mod of x. 3x mod of x. At x is equals to 0, now I would like to ask from each one of you, will you get the same answer, will you get the different answer? You will get the same answer. Either you feed x is equals to of 0 minus, either you feed x is equals to of 0 plus. Although the mod of x would have the different behavior, but once you feed their magnitude, the result is simply going to be 0. So I can say the first differentiation of mod of x cube at x is equals to 0 would be in parallel with the x-axis. Would be in parallel with the x-axis. This has been the first differentiation. Where? The first differentiation. That means the first differentiation is possible around x is equals to 0. Around x is equals to 0. So now I would expect from each one of you, you guys would be able to conclude its second differentiation. You guys would be able to conclude its second differentiation. Tell me, what would be the second differentiation of this function? What would be the second differentiation of this function? That is what I used to say. Better to attend my each and individual classes in sequence, because if you are not attending each and individual classes in sequence, probably you are going to get stuck in some critical points. This critical points is already been taught into the great detail when I was discussing about the absolute or the modulus function. Modulus function. Tell me, so if you had to take the double differentiation, you had to differentiate the past function once again. Again, the differentiation by parts would be chosen. See how the result would come. How the result would come. The 3 would remain as it is. Let's take at very beginning the differentiation of x has been taken place, which had been 1. The mod of x would be as it is. Mod of x would be as it is. Secondly, the x would remain as it is. The differentiation of mod of x used to be x divided by of mod of x, or either you can write mod of x divided by of x. Choice is yours. Again, I am saying until and unless you are not attending my previous class, how will you know what I am going to do over here? Sir, how differentiate mod of x? We have seen, Manju, we have seen that. So even you can write this as mod of x divided by of x. See what is happening over here? The x and x is going to go out, and here we had 6 times of mod of x. 6 times of mod of x. And now again, if I'll test its differentiability at x is equals to 0, again it would found differentiable, because at x is equals to of 0 minus and at x is equals to of 0 plus. The differentiation had been found to be very same, and that had been 0. That had been 0. Yes. Now, if you'll go with its third differentiation, what is happening? If you'll take its differentiation, the result would be 6 times of x divided by of mod of x. 6 times of x divided by of mod of x. And may I know whether this function is differentiable or not? You have taken already third differentiation of the given function. You have taken already the third differentiation of the given function, and at x is equals to 0 minus and at x is equals to 0 plus, the worth of the differential value or LHD and RHD is not same. The function would not have its third differentiation. Would not have its third differentiation. Could you understand what I am saying? So as far as this problem is being concerned, if first option is being given, only its first derivative is possible, that would be the wrong answer. Only second derivative is possible, or first as well as second derivative is possible, obviously that would be the correct most answer. If somebody says the function would have its third derivative at x is equals to 0, no, it won't be possible. Sir, whether 0 minus and 0 plus is same. Anyways, let me show this. Let me show this. I know many of the students would have the different kinds of the problem. For that, again, I would come back. Again, I would come back with a graph. What is happening? I think it has got logged, but it has been a very, very important question. Just a minute, just a minute, just a minute. I need to show this. I need to show this. Why it is happening, my dear friends. So I would request to each one of you, try to draw the curve, all of three curve. What are they? What are they? Let me go back. So use your Desmos and try to draw all of those curves. The first curve must be f of x is equals to of mod of x cube. And in beside of mod of x cube, you should also draw the mod of x which has been raised to 3. And just try to figure it out whether they have been forming the same curve or not. They would form the same curve. That's the first thing. And once you'll focus over the mod of x cube, you will see at x is equals to of 0. The function had been smooth. There had not been any formation of curves. That means its first differentiation would always be possible. Online plotter Himanshu, I am trying it, but still I am not able to get it out. Anyways, similarly, what you do, the second differential value, may I know how much we got it? We got probably this as 3x mod of x. And once you will draw the 3x mod of x, again you will see the function would be continuous as well as differentiable, because there would be a smooth curve formation at x is equals to 0. Again, it would be differentiable. But once you'll go with the third function, it would be formed as non-differentiable. Sir, use online plotter directly. Whew. Just a minute. Let me try once again last time. Again, the same problem is happening. No. So I would expect from each one of you, you guys would be able to smash this sort of problem easily. Let me go back into this problem. Any sort of doubt if you guys are having, no, you can ask over the live chat, because I know many of us would have the different kinds of the doubt. Tell me if any sort of doubt you guys are having. Any kind of doubt you guys are having. Okay, leave about the plotter and all. Let me draw the curve by myself. How the curve would look like, that you can see over here. Let's take this has been the x-axis, x-axis. This has been the y-axis. At very beginning, this axis has been dedicated towards f of x. This has been dedicated towards f dash x. This has been dedicated towards f double dash x. End of the day, I would be dedicating the another plane for the f triple dash x. F triple dash x. That we can also do. F triple dash x. Yes, what was the f of x? The f of x was mod of x cube. You can write mod of x has been raised to 3. How the curve would look like? The curve would be sort of this. You can draw by yourself. It has to come all the way towards downside. If it is just x cube, because of mod, what would happen? It would just get flipped towards upside. Then how 6 mod of x will be differentiable? We'll see now. Could you understand what I'm saying? Now tell me mod of x cube. What I'm going to do over here, now I would move slowly, because I know many of the students would have sort of doubt over here. As far as the x cube is being concerned, it has been sort of this, but just by multiplying minus of sign, it has got flipped towards upside. Now tell me the mod of x cube, would it be differentiable or non-differentiable at x is equals to 0? Would it be differentiable or would it be non-differentiable at x is equals to 0? As the curve had been smooth as well as continuous at x is equals to 0, nobody can stop the mod of x cube to be differentiable at x is equals to 0. Obviously, it is differentiable. Complete range of x, the function mod of x cube had been differentiable as well as continuous. Till this point, each and everything must be clear to all of us. Now what I did, I took the differentiation of mod of x cube. May I know what was the result over here? The result was, should I be writing over here? The 3 times of x into mod of x. Can I write 3 times of x mod of x as 3x square? Yes, I can. Why? Or no, just try to understand what I am saying. 3 times of x into mod of x. Can it be written as 3x square? No. See how it must be written over here. It would be 3 times of x square when the x is positive, and similarly it would be minus times of 3x square when the x is negative. So obviously you can bifurcate this problem into the 2 parts, when the x is greater than 0 and x is less than 0. May I know how the 3 times of x square curve would look like? It would be upper facing parabola. But now that upper facing parabola would have the different 2 parts. For the positive value of x, it would be upper facing, whereas for the negative value of x, it would be lower facing. The curve would change like this. Agreed? This would be your f dash x, which has been found to be 3 times of x mod of x. Now I would like to ask from each one of you, f dash x, which had been this curve, whether its next differentiation is possible along at x is equals to 0 or not. Obviously sir, it has been possible, because again the function had been continuous as well as smooth over x is equals to 0. So till this point, each and everything must be clear to all of us. It has been f of x, it has been f dash x. May I know what had been the second differentiation? The second differentiation which we got out of this had been, how much we have got it? So here it had been 3, probably 6 times of mod of x. 6 times of mod of x it was. Yes. So here it becomes 6 times of mod of x. 6 times of mod of x. The slope would be plus of 6. Slope would be minus of 6. So again, if I say whether the next differentiation of this function is possible or not, no, it won't be possible, because the formation of the curves has been taken place at x is equals to 0. And once you will take its differentiation, no, for positive value of x, the slope is plus of 6, and for the negative value of x, the slope had been minus of 6. And that is why the result of f triple dash x had been 6 mod of x divided by f(x). 6 mod of x divided by f(x). Fatafat get the answer. This has been the actual curve of the problem. Mod of x cube, the differentiation of mod of x cube, the double differentiation of mod of x cube, the triple differentiation of mod of x cube. And if you want how the differentiation has been changing like this, you yourself would be able to see. See, the differentiation of the f of x would be the magnitude of f dash x. F dash x is nothing but the differentiation of f of x itself, no? So the magnitude of the f dash x would be the differentiation of f of x itself. So for the negative value of x, you yourself would be able to see the slope was negative. That is why the magnitude of the f dash x has been negative for the all negative value of x. That's first thing. Secondly, the slope at x is equals to 0 had been found to be 0. That is why the magnitude of the f dash x has been 0 at x is equals to 0. And as for the positive value of x, the slope has been positive. That is why the magnitude of the f dash x was also positive. Similarly, as we were going towards this side, what was happening? The negative slope was keep decreasing, and you can see the magnitude which has been negative has been keep decreasing. And as you are going towards the positive value of x, what's happening? The slope is keep increasing. So that is why the magnitude of f dash x is keep increasing. In the same way, what is happening over here? What has been happening over here? It has been a parabola. For the negative value of x, the slope has been positive. You can see very well. And similarly for the positive value of x, again the slope has been positive. That is why once we took its differentiation, the differentiation of f dash x, which has been f double dash x, the magnitude of the f double dash x has to be very same as the slope of f dash x, and it has been positive throughout the length. And now if you take its differentiation for the negative value of x and for the positive value of x, you are getting the two different values. So I would expect that each one of us could have understood this problem very really well. If you have any sort of doubt, you can put it over the live chat. Otherwise, we would terminate our session here itself. Any sort of doubt you guys are having, you can put it over the live chat. Otherwise, we would terminate our session here itself. Still, I have been left out with the 3 number of questions. Probably I would take those questions in tomorrow class. But in tomorrow's class, I would probably instigate or start one new topic within the engineering mathematics. So what's going to be the best most answer? Mod of x cube, its first as well as second differentiation is possible, but its third differentiation is not been possible. Clear, no? So how many number of concurrent viewers are there? 8 number of concurrent viewers are there. If you guys are clear with this concept, you must write clear over the live chat, because this sort of problem may come in future for sure, because once it has come in gate electronics, the same question, mod of x cube. Sir, please provide the practice questions. Okay, we'll thought of it. Okay then, that is all about the today's class. We would meet in tomorrow's class with the EMFT over our Gate Academy 2.0 as well as mathematics on our Gate Academy Global. If you really want this slide over the Telegram group, what I can do, I can just post this slides over the Telegram group. So the student who have joined my Telegram group, definitely they can access this PDF easily. Clear now? Okay then, bye-bye, take care and good night. Any sort of doubt you are having, you can just put it over the comment box. So in future, whenever I go through the video once again, I would try to clear it out. Okay then, bye-bye, take care.